All right, so we are adding rational expressions. Minus 11x divided by the quantity x squared minus x minus 20 plus the expression 3 divided by quantity x squared minus 10x plus 25. All right, so you're adding these rational expressions. First thing you want to do is you want to factor the denominators as much as possible. So x squared minus x minus 20 is going to factor out as x minus 5 and x plus 4. And x squared minus 10x plus 25, that's what we call this perfect square trinomial. And that would factor out as x minus 5 to the second power, or x minus 5 times x minus 5, okay? And yeah, it might take you a minute or two, and that's fine. And if you still have some issues with the factoring, I would go ahead and look up one of the videos we made on factoring. All right, so the next thing is to grab or find the L.C.D, and the least or lowest common denominator. I'm sorry, I can't remember which is the word here for the L. And the way we do that is we start by looking at the first fraction, the minus 11x divided by x minus 5 times x plus 4. And we're just going to grab all the factors there from the bottom. So the x minus 5 and the x plus 4. And then we go to the next fraction, and then we ask ourselves, is there anything on this fraction, so the 3 over x minus 5, anything in the denominator, be more specific, that is there that is not in the first fraction, okay? So where you have the x minus 5 squared, is there something here, x minus 5 squared, that's not on x minus 5 times x plus 4? And there is. There's an extra x minus 5 here that we have on 3 over x minus 5 squared. So I'm going to write that down, yes, because x minus 5 squared, like saying x minus 5 times x minus 5. So even though we wrote an x minus 5, if it appears multiple times in another fraction, you need to include all the times that it appears, okay? And that would be our L.C.D, x minus 5 times x plus 4 times x minus 5, along those lines. And we will now go ahead and do the following. We want to get a common denominator. That was the whole point of part 2, step 2. So what we're going to do is we're going to go ahead and multiply each of these fractions by what is needed to make a common denominator. So I'm going to take both my fractions, the minus 11x over x minus 5, x plus 4, and then plus the 3 over x minus 5 squared. And I'm going to ask myself, okay, what is it? Am I going to multiply the numerator and denominator to get that L.C.D? So the first fraction, this minus 11x over x minus 5 times x plus 4, that's missing an extra x minus 5. So I'm going to multiply the top and the bottom, or the numerator and denominator, by x minus 5. And right, you have to do it to both. And for the 3 over x minus 5 squared, that's missing an x plus 4. So I'm going to multiply the top and the bottom by x plus 4. And those are really the main steps. I don't really have a step 4, 5, 6, etc. for this, because from here on out, it's a little more straightforward in my opinion, in terms of like things that we need to do. So the next thing is adding these two fractions together. We can add them because they have a common denominator. Plus 4, and then yeah, x minus 5 squared. And what I like to do is, these denominators are equivalent, they're just not written the same. I'm going to write them out as x minus 5, x plus 4, x minus 5. And what I'm going to combine, just like when you do with, adding fractions with just like integers, the bottom stays the same, the denominator stays the same, but you add the numerator, so the numerators will be added together. So is what I would have. And yeah, with the numerators, we're gonna simplify this a bit. So I'm gonna distribute that minus 11x. Here we get minus 11x squared plus 55x plus 3 times x is 3x. 3 times 4 is 12. Minus 11x squared plus 58x plus 12 all over x minus 5, x plus 4, x minus 5. And there you go. Now, the numerator sometimes can be simplified further, and what I mean by that is it can be factored further. Yeah, it can be. You can factor it. That's what I'm saying. Let me clean up that 5 there with the 58. There we go. So sometimes you can't do that. I'm not going to do that today, but please be aware that sometimes you can go ahead and factor that. And if you're asked to add, rational expressions, for the most part, at the end of the day, you're asked to simplify them as well. So any numerators, try to factor them if you can. All right. Well, thanks for your time.